Hi, my name is Shashank Singh Kumar, and today I'm going to be presenting my Lab 2 magnetic field of a bar magnet for Physics 2212. The purpose of the experiment is to measure the distance of dependence of a bar magnet and compare it to the values predicted by the Biot-Savart law. Important ideas include magnetic field, superposition of a magnetic field, and using computer models. Useful formulas employed include the Biot-Savart's law, magnetic field through the center of the loop, magnetic field of a dipole, and the moments of a magnetic dipole. The equations are mentioned next to the name of the equation. Methodology. So the first thing I did is I downloaded and used a magnetometer application on my mobile phone, and through the internet I was able to find out where exactly my mobile phone's magnetic chip is located. And so I marked that point on my phone. The phone was kept flat on the ground, and using the magnetometer app and by using two rulers, I was able to mark the x and the y axis. And by bringing a bar magnet close to the phone, I was able to measure the distance between the phone and the bar magnet, and I was also able to measure the effect that the bar magnet had through the magnetometer app on the phone. The assumptions that I made include the bar magnet was considered a perfect dipole for the experiment. I assumed that no human error is made, and I assumed that no other signals interfered with the magnetometer except for the bar magnet. Observations: as the magnet moves towards the magnetometer, the reading increases, and when the magnetometer is very far away from the magnet in a different room, it produces a zero reading in the x direction. The most important observation within this experiment is that when the magnet moves towards the magnetometer, the reading increases. This shows us that the magnetometer from the phone is working correctly and can help us produce data. So the results of the experiment are as follows. The magnetic dipole moment is 3.9 am squared. The measured off-axis magnetic field is 6.85 into 10 to the power minus 6t. The simulated off-axis magnetic field is 4 into 10 to the power minus 5 Teslas. The reason why the simulated off-axis magnetic field and the measured off-axis magnetic field can be due to various factors. The simulated off-axis magnetic field was calculated using linearization. So I linearized the graph that I received from the spreadsheet. What is significant about the data though is that the measured off-axis magnetic field is not equivalent to the simulated off-axis magnetic field. The following code is where I produce the simulated off-axis magnetic field from, and after the code I will display the equations which I use in order to calculate the measured off-axis magnetic field. The following two slides show the GlowScript model used in order to calculate the simulated off-axis magnetic field. You can pause the video to read them in detail. Over here we see a continuation of the code and the final result produced by GlowScript. The result clearly shows a bar magnet and its magnetic field. The following shows the data for the on-axis and off-axis magnetic field used to calculate the measured values. The Bx value was calculated for the off-axis magnetic field by taking the ln Bx versus ln R graph and then removing the lns by using various rules of logarithm. Over here I have shown the calculations involved in converting the ln Bx is equal to ln k plus n ln R formula to kr to the power n is equal to mu naught to mu whole divided by 4 pi mod of R cubed. This successfully connects the equation from the graph to the Biot-Savart law. All I have done is remove the logarithm from the original equation. What if in Y section? What if you had to compensate for the magnetic north? The magnetic field would vary due to another factor being included. The experimental and theoretical value are already different. They would still vary as another factor is added to both. This may make the experimental value closer to the theoretical value as another factor is being accounted for. What if you use two identical magnets stuck together? I think the direction will remain the same, but the strength of the magnetic field would double. Potential errors and final word. There may have been potential errors due to human errors in measuring physical properties, changing environment as different parts of the experiment were conducted at different times. Improper handling may have caused changes in the magnetic field. There may have also been certain technologies around my house which may have affected the magnetic field. Final word. Through this experiment, we have proved the significance that magnets have in our lives, and even from small bar magnets which may seem insignificant. Hence, the power of large magnets used in turbines would be hard to imagine. We employed the Biot-Savart's law that we had learned in class successfully. Thank you so much for watching.